Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. So we will continue this frame analysis, and in this session, I would like to focus on step number one only. Step number one uh, of analyzing frame using moment distribution method. Okay, we will learn how to calculate stiffness K, means the stiffness, the member stiffness and the joint stiffness. And after that, we will use the member stiffness and joint stiffness to calculate the distribution factor. There are 6 distribution factor because number of distribution factor uh, will be equal to number of end moment in the frame. Okay, the frame, this is the frame. The frame has 3 members, member AB, member BC, member CD, and each member has 2N. So in total, there are 6 member N moment. Start from MAB, MBA, MBC, MCB, and MCD, MDC. And the moment direction is assume the moment that act on the member is clockwise. So that is the first assumption towards the member and moment. Okay, step number one, and of course, we understand. I believe everyone understand using moment distribution method. We will calculate the member and moment as the outcome of this topic. So we will focus on the first step, first procedure, step number one. Step number one, we will calculate. We will calculate step number one, we will calculate K and distribution factor. In my video yesterday, I actually discussed under three short video about what is stiffness, the concept about stiffness, what is the factors influence stiffness. So please take some time to watch that as well. Okay, K. The stiffness is K, and to calculate distribution factor we must understand, and we must calculate the stiffness for the member and the stiffness for the joint, because the formula to calculate distribution is very important because we will use the distribution factor to distribute moment in the table. We will use distribution factor to distribute moment in the table. And what is distribution factor? So we actually can calculate distribution factor using simple formula. It is member stiffness divided by joint stiffness. Distribution factor is member stiffness divided by joint stiffness. Joint stiffness. Member stiffness, joint stiffness. Okay. Okay, now we look at the frame. Okay, always remember whenever we calculate stiffness, we only calculate the stiffness value whenever the member or the beam is between two joint, between two joint or between support. This is rigid joint, rigid joint. This is rigid joint. B and C for frame, we call this as rigid joint. For B and C in continuous beam, uh, at B and C normally the joint is subjected by roller support or pin support. But for frame B and C normally we call as rigid joint. So by looking at this frame, there are 3 members. We have member AB, we have member AB, KAB. So KAB is member stiffness. KAB is member stiffness. And to calculate KAB, the stiffness, because the formula of K of the stiffness is come from the modulus of elasticity, modulus Young. Okay, modulus of elasticity E, the E value I have discussed also in my previous my previous video yesterday. Okay, modulus of elasticity, and then I, the moment of inertia, it is also called as the geometry of the member of the element, or in the software, the I is actually the wording used for I to present I in the software is actually the section properties, geometry and section properties as actually refers to the I, the moment of inertia. And another thing is L, the length of the member. So these are the three factors influencing the K value, the E value, modulus of elasticity, the I value, moment of inertia, and the L, the length of the member. And don't forget the support also play an important role, because the far end condition of the member we will have to consider whenever we calculate K. So normally we will have two formula to calculate K. We will have two far end condition. One is called as far end fixed, like this, far end fixed, and another one is called as far end pin or far end roller. Pin and roller has the same characteristic. Okay, far end means for AB, far end refers to A. For AB, far end is refers to A, because B is internal and internal is assumed fixed. So that is why for the formula to calculate stiffness, so the term used is far end condition, far end fixed, far end pin or roller. So by looking at this frame AB, A is the far end and A is fixed. So we call this as far end fixed. And for far end fixed, the formula to calculate stiffness for far end fixed is 4EI over L. It is 4EI over L. 4EI over L. So since EI is not given, doesn't matter. We can just remain EI in terms of EI. So we just need to substitute the L value. So in the diagram, the length of AB is given as 5 meter length. So it is 4 over 5 EI. So we get 0.8. We get 0.8. Okay, don't get confused. K is for member, means that AB and BA is the same thing. AB and BA is the same thing. So AB and BA is the same things. AB and BA is the same thing. Okay, so KAB refers to AB and BA. Okay, it is 0.8. 0.8 EI. 0.8 EI. Okay, now we look at internal member BC, internal member, which is member BC. Okay, this one we use for internal member, we have to use 4EI over L. All internal members, we have to use 4EI over L. This is 4EI over L. Okay, so the member stiffness K for member BC, CB and BC is the same element. Okay, is 4. And look at the diagram, the EI for member BC is 2. The EI for member BC is 2. So we have to include in the formula 4 times 2 EI over the length. The length is 6 meter. The length is 6 meter. It is 8 divided by 6. it is 8 divided by 6. It is equivalent to 1.333 EI. 1 over 1.333 EI. It is 8 divided by 6. Okay, let me check. Correct. Okay, so this is K for member BC. Okay, next we look at member CD. Member CD has EI, and look at the member. Since C is internal, D is far end. D is the far end. So the far end for CD, for member CD, refers to ND, and ND is fixed. So we will use formula for far end fixed, and for far end fixed it is 4 EI over L. 4 EI over L. So for KCD, which also represent DC, it is the same thing. Okay, it is 4 EI divided by 9. It is 4 divided by 9. It is equivalent to 0.444 EI. Okay, 0.444 EI. 0.444 EI. So we have KAB, we have KBC for member BC, we have KCD for member CD. Okay, so this is the stiffness, the member stiffness. So what is joint stiffness? Joint stiffness is K at B, K at C. Okay, so we can conclude like this. This is member stiffness. So this is member stiffness. This is member stiffness. Now we want to look at the joint stiffness. Okay, what is the meaning? What is the meaning of joint stiffness? Joint stiffness means we want to find the total stiffness, the total stiffness at joint, the total stiffness at joint. So we focus on joint B and joint C. So we will have K at B means this is total K at joint B, consists of combination of K, B, because at B we have BA and BC for the end moment. We have BA and BC. So we have to combine this BC plus K BA first, BA plus K BC. KBA plus KBC. It is actually KAB, but because BA and AB is the same, so not to get confused, so we can also rewrite AB as BA, even though it is the same thing. Okay, so KB is BA plus BC. BA plus BC, that is the joint stiffness. Joint stiffness KBA plus BC. BA plus BC. So this one is equal to 0.8 plus 1.333 EI. It is 0.8 plus 1.333 EI. Okay, and this is equal to 0.8 plus 1.333. We get 2.133. 2.133 EI. Okay, next is K at joint C. K at joint C. K at joint C means CB and CD. C means CB and CD. So KC is KCB plus KCB plus KCD. KCD. KCB plus KCD, and KCB is actually KBC, and KBC is 1.333. 1.333 plus, and KCD is 0.444. 0.444 EI. So this 1.333 plus 0.444, we get 1.777 EI. Okay, so this is joint stiffness. This is joint stiffness. Of course, you don't have to show in detail like this in doing calculation, because you can the calculation of this is very simple, straightforward, and you can also put directly into the table. Okay, this is just to show you the step by step how to calculate member stiffness and joint stiffness. Okay, and after that we want to calculate distribution factor. Distribution factor. So distribution factor, for the distribution factor, okay, distribution factor, we have 6 because there are 6 member end moment. Distribution factor, we have 6. So we have DF at A, AB. Okay, we have distribution factor at B, we have BA, and we have DFBC, DFBC, and we have DF at C, we have CB, and DF at C, we have CD, and we have DF at D, DC. So in total, we have 6. It is equal to number of end moment, member end moment in the system. Okay, AB is the end of this, is the far end, the fixed end. Okay, and for end fixed, the factor is 0. So same goes to ND, DFDC, because it is fixed end, this is equal to 0. Okay, why we get 0? Because the K, uh the stiffness will be divided by infinity. That is why distribution factor for fixed end is equivalent to 0. Okay, for DFBA, what does it mean? DFBA means it is K, it is KBA plus KB. KBA plus KB. So we have KBA 0.8, KBA 0.8, KB is 2.133, KB is 2.133, it is 0.8, it is actually 0.8, 0.8 divided by 2.133, and this is equal to, okay, this is equal to 0.8 divided by 2.133, we get 0.375. 0.3, 0.375. The EI will be cancelled. Okay, for BC, because BA plus BC is joint B. BA plus BC is joint B. And distribution factor for joint is 1 except N fixed. Distribution factor at joint is 1 except except N fixed, like NA just now. Okay, so once we get BA, we will get BC easily because it is just 1 minus 0.375. Or we can also calculate using KBC divided by KB. So it is 1 minus 0.375. We get 0.625. 0.625. So total these two equivalent to 1. Distribution factor at joint is equal to 1 except N fixed. Okay, for CB, For CB, it is KCB divided by KC. KCB KCB is 1.333. KCB is 1.333 divided by KC divided by KC. KC is 1.777. So here is 1.777. So this 1.333 divided by 1.777, 0.75. 0.75. It is KCB divided by KCB plus KCD. Okay, so next, once we get CB, so we will get CD by using 1 minus 0.75. This is 0.25. Okay, and again, total distribution factor at joint C is equal to 1. Okay, so this is how to understand what is stiffness, which is include member stiffness and joint stiffness, and stiffness will be depending on three factors: the modulus of elasticity, the moment of inertia, or the geometry, or the or the what we call this the section properties. E is material properties. Modulus of elasticity is under the term material properties in the software. I is under term section properties, material properties, section properties. And another one is length of the member. And one important thing is the support condition, because we calculate based on the formula, based on the K formula, considering far end condition. For far end fixed, we use 4 EI over L. For far end pin, we use 3 EI over L. And from the stiffness for the member, we combine to have the joint stiffness, and from that, we calculate distribution factor using simple formula, member stiffness divided by joint stiffness. And remember, the distribution factor for n fixed is equal to 0. Distribution factor for n pin or roller equivalent to 1. And distribution factor for each joint is also equivalent to 1. Means that when we total DFBA plus BC, we get 1. DFCB plus CD, we get 1. Okay, so we will use this distribution factor in the distribution table to distribute moment. Okay, for the next video, we will move to step number 2. Step number 2A. Step number 2A is how to calculate the fixed end moment due to external loading. We will meet again in the next video. Thank you very much.